Children, children, stop. You could use this blue card on the quiz Friday. It now we did the three types of problems here, right? This first group was when we launched something, right? It had a velocity, and we had to find the vertex. And then we had when we dropped an object, right? Like, maybe I'm just saying, maybe one of your parents dropped somebody on their head when they were a kid. That would be dropping, right?
I don't know.
I'm not.
There's a lot of those that probably happen.
All right, and then when it hits a certain height, that was the basketball one, right? So we're either going to be looking for the vertex, the x-intercept, or sometimes both. Now, I feel like doing these problems for you, you're not like gaining the potential that you should. So I'm going to do one of these problems, and you guys really, really need to work on these so that you know how to do them, especially for the quiz on Friday. I can't keep doing all the problems for you and then expecting you to learn them. Okay? So I gave you another homework sheet. It says even more quadratic applications, right? And I'm going to do the Maya shoots the arrow upward one. So number 2 there. And then this will probably be the last one I do. You guys should do the rest of this worksheet and the review by yourselves. And maybe tomorrow come with questions instead of a blank sheet of paper with nothing done on it. Try to do some of this stuff at home. All right, so number 2. Maya shoots an arrow upward, and the height of the arrow at t seconds later is given by the equation h of t equals negative 16t squared plus 175t plus 3. And again, with these, I always tell you guys to do what? Make a sketch. Okay. And again, I like to focus on that first quadrant because, that's where all the action happens, right? So instead of my x-axis, I use t for time. My x-axis is a time axis. And then the y-axis is the height. So I'm going to use h for the height, y-axis. All right. So let's read this. Maya shoots an arrow. So we're launching something, right? So we shoot this arrow up, hitting velocity, and then it's going to stop, and eventually it's going to come back down, right? So again, with these problems, we're looking for maximum height. So the vertex here, right? T comma H or X comma Y, however you want to think about it. Your calculator, uses X, Y. So we have to find the highest point, which is the Y value or the H value of the vertex, and the time it takes to get there. So that would be this T value or the X intercept. Or no, it is an X intercept, but at the maximum height, that's where we want to know how many seconds this is. Then some of them, and that's the reason why I picked this problem, wants to know when it hits the ground. So that's really our x-intercept, but remember we're using t. So it's the t-intercept. And there's all kinds of names for that x-intercept. If you want to think about it as the x-intercept, go ahead. Remember we called it zeros, roots, solutions, all kinds of names for that. We're calling it the x-intercept or the t-intercept. Your calculator calls it the zeros of the equation. At the y value or the h value of this intercept is, remember, 0. And when we were looking for intercept, we did this in looking for intercepts in algebra previous sections, we always set the y equal to 0 to find the x intercept. So here's my picture of every possible thing I would want to know in algebra 2 for shooting an arrow up in the air, right? All right. Hopefully you grabbed your calculators and you do this with me so that you guys, it starts, you're able to start manipulating the calculators. Because this is not, I agree, this is not easy to do on your calculators. So that's why I want you guys to do it with me on the calculator. All right, one of the first things you have to do is go to your y equals, clear everything out of there, because we want to start from scratch on your calculators because we don't know what other classes have done what to the calculator. There's even an AP stats course in here. So be careful that your plots are not on because they'll turn these plots on and use them for statistics. See how I can turn them on with the enter by hitting the enter button? Make sure these are off because we're not using plot and it won't work for our graphs. So make sure your plots are off. Go to your zoom. Make sure you hit zoom standard, bring it back, your graph back to your default settings. The scales from -10 to +10, right? So go to zoom standard, and there's my standard graph. And then put your equation in. Okay, for this one, we've got, did I miss your hand? I'm sorry. Um, put your equation in there. -16. I'm using x squared, so x squared plus 175 x plus 3. Okay. Now I'm going to hit graph, and this is going to be a really, really big parabola. Okay. In fact, I'm only getting like a little partial of the parabola here, and it's almost like almost right on top of my y-axis. All right, I talked a little bit about when this number is big yesterday, right? I didn't talk about when the b coefficient here, when this number is big, it's actually being multiplied and added. Remember, if we were to factor this, the outer, inner, we multiply and then we add those two together. So this is really a huge number. Okay. I'm when I go to my window here, I'm not going to put like 200 in for my Y max. I'm going to put something in like 500 because this is a really big number for this coefficient's a big number. So I'm going to put 500 in there and just see what happens with my graph. And there's my parabola. And I barely caught the max there using 500. So when you have a large B, use a really large Y max for your window. Now, I know I did this problem already for my other class, and I know we need that X intercept. So I need more of the X axis. So I'm going to go back to my window. Right now, my X is going up to 10. I'm going to put this up to, I don't need a whole lot more. Maybe I'll try 15 and hit graph. And let's see if it picks up that intercept. Yes, it does. Okay. So I can get the vertex and I can get the X intercept here. All right. So I think I'm pretty good. Now, a lot of these papers, a lot of these exercises, they have, well, what did you use for your window? Everyone's probably going to use a different window. So you don't need to put all this stuff down. Okay. I'm okay with it not being there. Because I know a lot of you are going to have different windows. All right, so let's answer some more questions. What is the maximum height and when does it occur? So I need that vertex. This is asking me for the vertex, right? So my parabola opens downward, so I need the maximum. Your calculator is going to call that the maximum. And again, I'm just following the notes here. Okay. Finding the maximum or minimum. I'm going to hit second trace. So second trace. And I'm going to, number 3 is the minimum, number 4 is the max. So I'm going to hit number 4 for the max. And I need a left bound. Well, I'm going to get a little closer to the vertex. That would have worked, but I just want to be a little closer. So I'm going to hit enter. There's my left bound. Here's my right bound. Get to the right of that. Hit enter. And then hit enter again. And there's my vertex. So I'm going to go to the tenths. So 5 point, let's see, 4, 6. 6 is bigger than 5. I'm going to round it up to 5, comma, 481 point. See, 1's lower than 5, so I'm going to keep the 0.5. Remember, this is my h, my height, and this is my time. So my maximum height is 481.5. And I think this is feet. May not say feet, but we'll call it feet. And the time at 5.5 seconds. Okay. When does this object hit the ground? So now they're asking me, well, here's the x-intercept. I know the h is 0, but I don't know what the x is or the t, what time it is. They want to know this total time, right, when it hits the ground. That's my t-intercept or x-intercept. So I'm going to have to calculate that on my calculator. Now, let's just calculate it, okay? Let's use the blue sheet. There is a way to kind of cheat sometimes on this, but we'll just calculate it. Hits the ground. I'm going to hit second trace. So second trace, number 2, and that's the 0, 1. Okay, so I need a left bound. I got to be, now remember, I'm trying to find this point. So I need to be to the left of this point. I am already, I could hit enter, but I'm going to get a little closer. Okay. Still to the left, I'm going to hit enter for my left bound. We're doing the max. The 0, I'm sorry. We're finding the x-intercept, the 0. So I have my left bound. Now I got to get to the other side of the x-axis. When you're looking for the 0, you have one of your bounds is above and the other bound is below. So I'm going to bring my cursor below that x-axis, somewhere below it. I know it's below it because I saw it cross the line. I'm going to hit enter and then enter again. And my x-intercept then is at 10.95. If I want to round this, round up to 5 to the 9. So I'm going to call it 11 seconds. Now, before you go elsewhere, it says 10.95, comma, y to the e, negative 1 e to the negative 10. How did I know that was 0? What does that mean? E to the negative 10. Scientific notation, isn't it? That means your calculator is saying, well, this y point is, we got 10.95, comma, point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros be hit before we hit 1. Your calculator is really trying to be as accurate as possible, and it reached a number way out there, and it can't even display that number. Okay, it can't display it because it doesn't have enough pixels. This is actually zero. Your calculator telling you, hey, this is zero. It's just trying to be really accurate, and it can't just tell you zero. So this is actually zero. When you see something with that e to the negative, it's zero. Okay. Complete the table to show the heights. This is the easy part, right? Because I just go to my table, second graph, my table. I look for when my x values are 2. I plug it in what the y value is. So at 2 seconds, my arrow is at 289 feet. At 3 seconds, it's at 384 feet. And at 4 seconds, it's 447 feet. Then it's asking for the rate of change, the average rate of change, because it's an inconsistent slope, right? So it's an average. And that is delta, the change in h, divided by the change in t, or the change of y over the change of x. Okay, the change of, well, they tell us t here. Let's put the t's in. 2 to 4, so 2 minus 4. Now the h for 2 was 289 minus the h for 4 was 487. Let's see. Way too much for me, too early in the morning. Not enough coffee. 289 minus 487, 198. Is that right? Minus 198 divided by negative 2 and divide by negative 2. I get 99. Let's say feet per second. Questions, comments, concerns pertaining to math. Now, you guys should do this during class time. Please don't waste this time. This is the only time that you're going to be able to use, everybody gets to use the same calculators. Mrs. Meyer, myself is here to help. Um, you guys got to use this opportunity because come quiz time, I don't. You're not gonna like. How do you do this on the calculator? It's too late. You got to do it now. Are we good?